this week. This week we have seen some content on the signals and systems that are useful for control engineering. So today we'll be seeing some of the problems that will be helpful for your practice assignment. So we will start up with the practice assignment question itself. You can go to the practice assignment questions from your portal. Quizzes. It's not confirmed yet. Mostly it will be the multiple choice questions that. Yes. One or two questions might have some short answers like kind of calculation and fill in the blanks with some answers like numerical answers. Yeah. Haha, yeah. I can confirm you on Friday. Fine. If you have taken the practice assignment question, you can see it on your screen. So I will just dictate using this PPT. Okay. Once you open, please confirm. Give a thumbs up. I will start. So this is going to be a discussion session on the assignment questions, practice assignment. So based on this idea, you can solve the assignment. We can discuss that on the Friday also. Have you people tried Have you people tried solving it? That practice assignment questions. Week 2. No, okay. We'll go through that and I will let you solve. Yeah. What is your question? Is it? Yeah. Yes, the second week content what we saw on the Monday. So we have a deadline for week 1 till 25th May, right? Both 25th, right. We'll try to solve these problems. Okay, once we open the practice assignment quiz 2, the first question is which of the following are true regarding the Laplace transform and its application to convolution. So for that, we'll just touch upon the convolution and the Laplace transform once and we can move ahead with that. Okay, first of all, convolution we have seen in 3 different domains. One is time domain, frequency domain and in S domain, right? So convolution basically means using 2 signals you will get the third signal, or else if you want to interpret in another format, this will give how the system responds. If you give an input and by convoluting that input to that output, we will get by convoluting that input to that system impulse response, we will get some output out of it. Okay, so this is a mathematical operation that combines 2 functions to produce a third function. It expresses how the shape of one is modified by the other. One function is modified by the other. In our context, it can be described how an input signal is processed by the system to produce an output. So these are all the overview of the convolution. So convolution, mathematically it is represented using this formula. If we want to find a convolution of, let's take signal x of t and h of t, where h of t is the impulse response of the system, then the output will be y of t is equal to integral 0 to infinity x of tau h of t minus tau d tau, where this involves shifting and time reversal. Okay. First, the impulse response of the system, it should be first time reverse and then shift by t. Then we are multiplying it with the input signal. That's how convolution is being defined. Okay. Then comes the Laplace transform. Some notion of the Laplace transform if I want you to know is, Laplace transform is another tool that can use to represent the signal in some other domain where it involves both exponential function and the frequency function. Okay, sinusoidal functions. Where Laplace transforms can be expressed as, where it is, let's learn next. So by convolution, we know the formula for finding Laplace transform. This is the representation where you are multiplying the input signal with e power minus st dt and you are transforming the time domain to the s domain. This is for finite integration. Okay. Then comes the region of convergence. Region of convergence meaning this integration we are taking for a signal, right? This cannot be guaranteed that every time it will converge. It might be a finite value or it might not be a finite value. It might be the infinite value. So whenever, take the case whenever it converges. It might be converging or it might not be converging. Take the case whenever it is converging. So this ROC refers to this. What are all the finite values for the particular S value, for this particular S values? Collection of all these finite values for that particular or that respective S values. That collection we call it as region of conversion. For example, the signal is convergent for this region. So the system's region of conversion is this. Apart from this, it might go to infinity. That's what the region of convergence represents. Okay. So for the first question that involves both Laplace and convolution, we have got some idea about this. So you tell me what are all the statements that are true. Let's take the first statement. The Laplace transform of u of t is 1 by s for all s greater than 0. What is u of t? U of t, true, right? Yes. U of t is the step signal where it will be like this. At 0, it starts to be at a finite value and it will be at that final value forever. So this is a step signal. It is telling that the Laplace transform of step signal is 1 by s. So we know that Laplace of u of t will be 1 by s. That is there in this properties, right? See, Laplace of ramp is t. We have seen this table, right? Laplace of impulse is 1, Laplace of step is 1 by s, ramp is 1 by s square, parabolic is 1 by s. Right? So these are all some standard signals. So the first statement is true. The second statement is convolution in the time domain shifts the ROC of the Laplace transform. Is it so? How and why? If yes, how? If not, why? Can we see one example so that we can understand this better? Okay. So first of all, how do you find an ROC of the system? How to find an ROC of the system? Before that, we have to see what is causal system and non-causal or anti-causal system. Causal system means whatever system is, for example, if x of t so causal systems are x of t is equal to 0 for all t less than 0. So this might have some value, but whatever value that is t less than 0, that will be the x of t will be 0 for all the values. That is true for causal systems. For anti-causal system, this is the reverse value. This might or might not have some value, but what are all the values that we consider where t greater than 0, the signal would be 0. That is anti-causal system. So for causal system, the region of convergence would be positive, greater than 0. Okay, for anti-causal system, it will be the opposite of that. If you see take some example. For example, if I am taking the e power minus 3t u of t. How do you find the region of convergence for this? How do you say that for what values of s this will be finite? The value of this function will be finite. The first step is to take the Laplace transform of this signal. As this is a straightforward signal, we can say x of s, that is Laplace transform of x of t. This is x of t xt. Laplace transform of x of s would be 0 to infinity x of t e power minus st dt, right? So here if I substitute instead of x of t, e power minus 3t, u of t is 1, so I am just leaving as it is, e power minus st dt. So this can be written as 0 to infinity e power minus s plus 3t into dt, right? So integrating e power x would be e power minus x by minus x, or minus e power minus x by x, right? So this would be e power minus s plus 3 by minus of s plus 3 at 0 to infinity. So this will give, when you substitute infinity here, e power infinity 1, 0, e power 0, 1. So already there will be a minus, so this will be 1 by s plus 3. So how will you say the region of convergence here? Now this is the Laplace transform. The first step is to find the Laplace transform. The second step is to find where these values will be greater than 0. Right? So where these values will be greater than 0. When this s plus 3 will be greater than 0. Whenever s greater than minus 3, is it right? So, yeah, for region of convergence, we will just consider the real value, not the complex value, because the S domain consists of zeta plus j omega, right? We don't bother about the frequency, we just see how the real part. So the real part, whenever this is greater than minus 3, at that point, all those points, this will be finite. This x of t will be finite. So this is the region of convergence of these things. Okay, right. The question would be, the convolution time domain shifts the ROC of the Laplace transform, right? So how are we going to answer that based on this idea? So we have taken this example, right? E power minus st u of t. I will give another one. Consider this as instead of x of t, consider this as h of t for our convenience. Now I am going to give another x of t, that is e power minus t u of t. Consider this. What is the Laplace transform of this would be? The Laplace transform of x e power minus 3t u of t would be 1 by s plus 3. Then for e power minus t u of t, it will be what is the answer? Anybody? Yeah, right. 1 by s plus 3. Then the region of convergence would be I won't write unless you speak. What is the region of convergence for this? Yeah, right. This will be real part of s will be greater than x. Okay. So for all these two signals, e power minus 3t u of t, e power minus t u of t, this region of convergence will be greater than minus 3. This is greater than minus 4. We know this. Now, if I convolute this, u of t into u of t is equal to x of t into h of t. So when I convolute this, I don't have to do all these things, right? Instead of calculating all these things so far, I have the Laplace transform of this. So convolution in time domain will be multiplication in line, yeah, frequency domain, and also in the s domain. Right. So this would become 1 by s plus 1 into 1 by s plus 3, right? Now this will be like you want to do some partial fractions and all, but if you formulate after doing all those things, you would find the real part of s greater than 1 intersection, real part of s greater than minus 3. So this would be, does it alter the ROC? If you find this, the final real ROC of this intersection or convolution would be within this. Yeah. So it doesn't alter. So the statement it was given there, convolution in time domain shifts the ROC of the Laplace transform. Is it true? No, right? It doesn't transform anything. So the second statement is false. First statement is true. Oh, third. Adhika. Right? This is the final conclusion. If I come to the third statement, the Laplace transform of convolution of x of t and h of t is x of s. That we already proved now, right? So the third statement is true. The fourth statement, the Laplace transform is valid for both continuous and discrete time signals. Everybody agrees? It is for continuous time. Okay. No. This with I'm sorry. Both, it's valid for both continuous and discrete time signals. We have a representation for discrete time signals. No need. It's valid for both. It is about discrete time signals. Laplace transform can be taken for both continuous time and discrete time signals. It will be valid for both. Okay. Ah, okay, okay. Then you can go with whatever priority. If this is just for learning, right? So you can go with it. Okay. The second question is, going to the second question. The final value, they are asked to find the final value of x of s is equal to 2 plus 1 by square 4 plus 8 s cube plus 16 square plus s. Okay. So this is the we have to find the final value of this. Can you recollect the final value theorem, or should I go back to this one? Do you remember, instead of doing limit t tends to infinity x of t, we can do just simplify. Yes, s tends to 0, s into s f of x, x of x, right? For x of t, it's x of x. Should be capital. Okay. So it is already given in x of s. The work you have here is just to simplify this. You see, by substituting x tends to 0 everywhere. That's it. If you have some common term, just pull out the common terms, cancel all those things, and then substitute the s. Otherwise, you will straight away get infinite values. Okay. So there are some common terms here, right? If you take the s outside, this will be s cube plus 8s square plus 16s plus 1. In the numerator already there is one s, so this s and this s will get cancelled. The rest of the numerator will have only this thing. So if you, what? Well, final answer is, so if you substitute 0 to all the s here, this everything will go out, then the final answer will be, that is the final. If you just ask to find the initial value for the same system, how will you do? Yes. Yes, just the s should be replaced by infinity, but the questions won't be like this, just to understand the concept. Right? The question will be like, it will be feasible to calculate. The next question is on that, to find the initial value of x of s is equal to s plus 1 by 3 into x minus 1 into x plus 1. Right? Now, what is the initial value theorem we have to use? Similar to the limit t tends to 0, x of t will be here limit s tends to infinity s into x of s. That's it. Just substitute the x of s here. Again, take the common terms out and try to erase all the terms if that is possible, and then just substitute. Yeah, if you first take out the common terms from there. What is the answer you are getting? No, what is the answer you are getting? Yeah, right. Same. So it can either be like this, or you can simplify this to, which will be easy in this case, otherwise you have to face the fractions and all. Then this will be square by, this can be approximated into 3s square by 3, s square by 3s square. This s square will get cancelled, then this will be 7.5. Right? Everybody with us? Anyone have any doubts so far? Yeah. Mm. You should see that name, you should compare that name with the time domain. Initial value means time domain, t tends to 0. But in S domain, it will be opposite to that. For final value, t tends to infinity, so S tends to 0. That's it. So please don't get confused with this, okay? Right. The fourth question we will move to that. We are asked to find the Laplace transform of e power minus t, t minus 2, u of t minus 2. So sometimes the questions seem to be very lengthy. The point is you should know how to simplify it first. Then if you find a way to simplify it, it will be easy to solve it then. The first thing whenever you try to do is, in Laplace transform while solving it, look for properties that match the question. Right? So go think about the properties that can be easily replaced, that can replace the question easily. So I will just go to the slide. Keep this in mind. Okay. So properties of Laplace transform means anything. I will just scroll through it. If you find anything that can be easily replaceable to this, or any idea if you get, just stop me there. Let me know what you think, okay? The similarities in this question is, this is t minus 2, this is t minus 2. But this is t. Somehow you have to make all those things into one. That is the first catch you have to solve. So anything you can see that can be. Right, okay. That is one way. So if you want to solve this in your way, you are telling e power minus 2 into e power minus t into t minus 2. Then there will be e power 2, right? E of t minus 2. Am I right? That is what you told? Someone answered, no? I'm asking. Yeah. So this will be e power minus 2 Laplace of e power minus t minus 2 into t minus 2 into u of t minus 2. Good. Now we got all the things in the same t minus 2 form. Right. Now we'll try to solve some technique or some shortcuts properties so that we can replace this with a single. There is a this t minus u, time shifting. Can we do anything with this? Whenever the x of t is with the time shifting property x of t naught, if I take Laplace transform to this, I can write it as e power minus s t naught, where t naught is the time difference, into x of s, the actual Laplace transform of that particular value. So how can we write this? Can I write it like e power minus 2 into e power minus 2s, because the time shifting here, the t naught is minus 2, right? So e power minus 2s Laplace of, till I haven't solved it, so I'm just keeping Laplace as it is. So e power minus t into t u of t. Now also everything is on same thing, right? Only t, instead of t minus 2, I just made it simple to t, right? Any doubt in this step? Right. How we can solve from this? Can we take this u of t to 1? Right. Then this will become e power minus t into t. Did you see anywhere this kind of problem? Yeah, right. I think we have solved some example on this. I'm looking for it. Never mind. Okay, then this will be, if for e power minus at, this will be 1 by s plus a. T into e power minus at will be 1 by s plus a the whole square. That's it. That replacement we have to do. Then this will be e power minus 2 is, this will become 1 by s plus 1 the whole square. So I'm again rewriting this into e power minus 2 into s plus 1 by 1 by s plus 1 the whole square. Right? I hope that will be there in the option. Right here. Okay. So if we just give e power minus t power t minus 3 and u of t minus 3, you will be able to solve, right? Otherwise, instead of step signal, if we give ramp signal, how this will be? Thus, all these things, I hope you will be able to solve. If you have any doubt, please ask me right now. Otherwise, we'll move towards the fifth problem. The idea behind this is, whenever you are asked to solve some problem, first try to replace the question using some properties, some shortcuts, whatever known concepts you have. Try to simplify it first, then try to solve those questions. Okay, moving towards the fifth problem. Find the convolution of r of t into u of t, where r of t is a unit ramp, u of t is a unit step signal, with cos t applying the convolution theorem. First, when I read this question, it was very confusing for me. I have read 2-3 times over this. What they want to convey is, first they are taking one signal. That signal is a multiplication of r of t into u of t. Then, where this r of t is the unit ramp and u of t is the unit step signal. Then they want to find this convolution between x of t into cos of t. That's it. That is the question they want to answer. First, how will you represent r of t? Will be t, right? U of t is equal to 1. Then the x of t simply becomes t, right? Then h of t is equal to cos t. They want to find the convolution between these two. How to find the convolution between x of t into h of t? Is it right? Am I doing the right stuff? Any mistake I did? Okay, there is a catch here. Yeah, right. So unless you are asked to solve in some particular method, just go with the Laplace domain. That will be easy for you. Find x of s, then find h of s, multiply both, you will get the convolution of this. Right? What is the if x of t is equal to t, what is the Laplace transform of ramp? We already seen that, right? What is the Laplace transform of cos t? S by s plus a by s square plus b square, right? So just find then the x of t star h of t would be x of s dot h of s. Then this will be 1 by s square into 1 by s square plus 1 square. Since it is cos t, I am just replacing a with 1. Then this will become s 1 by s into s square plus 1 square. Do partial fractions. Instead of cos t, because cos a t, here a equal to 1, that's it. Just do partial fractions and you will get the answer. That's it. Right? Can you do this and tell me the answer? So after doing partial fractions, when I find the quotient of a, b and c, and if you substitute, you will get a answer like this: 1 by s minus s plus s square plus 1. Where if you find the option, it is represented in t, right? Time domain. So we have to convert this back to the time domain, s domain to time domain. Again we have to convert. Just use the inverse Laplace transform, try off the shelf method, and you will get the answer for it. So 1 by s, what is the inverse Laplace transform of 1 by s? When you take Laplace of unit step signal, you will get 1 by s, right? So inverse Laplace transform of 1 by s will be unit steps. Right, okay. And again this is s by s square plus a square format, so you can write cos t. So the answer will be 1 minus cos t. I hope there is no doubt in this. So whenever you are asked to solve convolution method, the takeaway of this question is, first try to take Laplace transform of this question, multiply those two signals, then do inverse Laplace transform if the options are in time domain, or just leave it as it is. If the options are in s domain, just choose that. Okay, we will move towards the last question. We are asked to find the impulse response of the system. Two d square y by dt square plus 7 dy by dt plus 6 y. I am not using the of t, y of t, instead of I am just simply writing y and x, right? So first thing, I will rewrite this for my convenience with dots. It will be simpler to see. Right. So what is the differentiation equation of Laplace transform? If you find first order differentiation, yeah, it would be s into x of s minus x of 0. For second order, x square x of s, x of 0 minus x dash of 0, where this is a differentiation of this initial conditions. Okay, right. Okay. These two we are okay with the, since our highest degree is 2. Did they give any initial conditions so far in the question? Then assume all the initial conditions are 0. Okay. So we are left with, how can we write this equation? This equation can be replaced by y2 into y of, yes, right, mistake. 2 is squared into y of s minus, I am just skipping all the initial conditions. Instead of putting 0, I am not writing it, don't get confused here. S into y of s plus 6 into 6, right, is equal to 3. Am I right? So rearranging this, you would get 2s square minus 7. This will also be y of s. Okay. Taking y of s common, 2 square minus 7 is plus 6 equal to 3 into x. If I want to find input by output, that is for transfer function, S domain. You know the definition of transfer function, right? Laplace of output by Laplace of input of a system. So we are just writing it in terms of transfer function. So this would be 3 by 2 square plus minus 7s plus 6. Okay? Is it there in the option? Is this answer there in the option? Yes. In the time domain, we have to find the inverse Laplace transform of this. For that you need to do again partial fraction. That's it. If you find partial fraction, you will get two s values, then you will do a plus b by won't it be minus 7? Okay. I made a mistake. It will be plus 7. Okay. Then when you do the partial fraction, you will get the final output. Just do inverse Laplace transform and you will get the final output. The correct option would be 3 into e power minus 1.5t minus e power minus 2t. That would be the first A option, I guess. Yeah, it's A option. Okay. Anybody have any doubt in this practice assignment session, or do you have any other problems in your mind you want to discuss? I know, yeah. The reference book that are in the website is enough to understand this, I think. Nagaraj Gopal, Ogata, those are all the reference book it was suggested, right? That is enough. There you can see the detailed things there. Right. I know when you try to solve assignment only, you will get some idea or deep thoughts, doubts in this question. So save that for Friday class. We can discuss that in detail. Right. I will take attendance data and you can hurry. Right. Alkesh Srivastava. Okay. Dhruv. Dhruv, are you there? Okay. And Vinayak. Who? Yeah. Right. Yeah. Ah. I will open that. I got locked out. You will get s into s plus a something into s plus b something, right? You will just have to use a plus b. That's it. A by s plus something plus b by s plus something. Whatever value you get. You don't need to do b s plus c as in the previous problem, because there was a s square term below, right? That's why we wait. I'll present it. See, there was a square term here. That's why we did bs plus c here. But here there won't be any a square term. If you yeah, right. It will be ab by s plus something. That's it. Okay, right. Vinayak, Vinayak, are you there? Oh, he left. Okay. Am I audible now? Okay. Right. Okay, right. Vinayak, you are there, right? You gave attendance. Right. Rajdeep, okay. Manisha, Sayan, Vishal. Okay. Right. Right. If you have any doubts, you can ask me now. Otherwise, you can leave. Yeah, we can solve more problems on Friday.